All right, so this is going to be our notes over the sun, earth, and moon. And then we'll also talk about later on the planets. So as we study outer space, we know that the view from Earth is constantly changing, and that's due to two things. The first one is Earth's movement around the sun, and then also its movement on its axis. Both of those are going to change the view from Earth and the view that we get of outer space as well. When we talk about planets later on, a planet is going to be a celestial body that orbits around the sun, is going to be round in nature due to its own gravity, and then also is going to have a clear path for its orbit. In order to be considered a planet, you must have those three characteristics. That is crucial. When we look at the sun is going to be the closest star to Earth. It has a diameter of 1.4 million kilometers and a mass of 330 times that, or 330,000 times that mass of Earth. The sun's effect on Earth. It affects us in several different ways. There's four located down below. We can see that it affects our human activity. So as we have our daytime and our nighttime, we are more active during the day and we rest at night. This is common for a lot of animals as well. Plant growth is also affected by the sun, as there are growing seasons for plants. They rely on the sun for photosynthesis, and so what you'll see is that some plants will actually open up during the day and then close back down at night. And then when we look at the weather and the ocean currents, those both are also going to be affected by the sun and the sun's gravity. Heavens for a long period of time. This started with the Greeks and the scholars. They were the first to study the skies, and they found what are called constellations. Constellations are going to be groups of stars that they organized into a pattern, and they were used as a reference point for traveling. The Greeks also found 5 planets when they studied the heavens, and they were able to calculate that some stars were farther away than these planets and other stars due to how they changed in the sky. Later on, the invention of the telescope allowed for people to find more objects in the night sky. 2 more planets, both Uranus and Neptune, were discovered, and then other large celestial bodies such as Ceres and Pluto were discovered as well. Our solar system is going to consist of the sun and all the planets and the other celestial bodies that travel around the sun. The sun makes up 99% of the total mass in the solar system. So it's very massive compared to even those other planets that are bigger than Earth. Planets are kept in orbit due to this gravitational pull and attractive force that is found due to the sun and its immense gravity. All planetary bodies exert gravitational pulls on each other. So the Earth is pulling on Neptune. Neptune's also pulling on the Earth. And because these planets are going to be further away and not as great in their mass as well, you won't necessarily realize or feel these forces. Our solar system consists of 8 planets. That'd be Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And those are listed in the order from closest to the sun to furthest away. The planet distance from the sun determines how long it takes to orbit the sun. Pluto is not considered a planet, and this we'll look at later on, but its mass is actually too small to have a clear orbit around the sun, and therefore it's not going to be considered a planet by scientists. Our solar system also has several smaller objects known as satellites. These satellites are going to be objects that will orbit around another body that has a larger mass. And what you'll find is that many of the moons that are located inside of our solar system are going to be classified as satellites as well. So, for instance, our moon, which is Luna, is going to be Earth's satellite. There's going to be all planets in our solar system will actually have moons, except for Mercury and Venus. And Jupiter's Ganymede and Saturn's Titan will actually be two moons that are going to be larger than the planet Mercury itself. So you can see this one is Ganymede that has all these craters on it. And then Titan actually has its own atmosphere that makes it very similar to that of Earth. Our moon, which is Luna, orbits around Earth and not the sun. Its surface is covered with craters, and these craters are known as Maria. Maria comes from the word the marine or the ocean, and so these dark patches were thought to be water sources, and it's actually going to be craters, areas that lava has actually flowed out of the interior of the planet, filled those craters, and then cooled, and that's where we get that dark color from. The moon's effect on Earth, it affects our tides. We have two tides a day, two high tides and two low tides a day. And it also goes through what we call phases, which is the changing in the illuminated area of the moon caused by its position of Earth, or the position of Earth, the sun, and the moon. So you can see here in this picture, we have several different phases that the moon will go through. So if you were to look up at the sky at any time throughout the night and you see the moon, it's going to be in one of these phases. And you can see the phases are going to be characterized by where the sunlight comes from on the right side, and how it shines and either is going to be reflected back by the moon, giving us a new moon, or going to illuminate the moon, which will give us a full moon. The moon will also have what we call eclipses. This is going to be an event in which the shadow of one of our celestial bodies will fall on another. So when we have a solar eclipse, this means that the moon is actually positioned between the sun and Earth and is blocking out the sun's light. And therefore, for a brief moment, we do not have sunlight. You may have remembered a couple years ago, we had a solar eclipse and our district got those glasses out and we were able to observe the solar eclipse. Lunar eclipse is going to be the opposite. It's now where the Earth is going to be positioned between the sun and the moon. So the moon's on the other side of the Earth, and now the Earth's shadow is going to block out our image of the moon. Okay, so now let's talk about inner and outer planets. Our inner planets, there's 4 of them. This is going to be Mercury, Venus, Earth, and Mars. They are known as terrestrial planets. The reason why they are called terrestrial planets is because they're relatively small. They have solid rocky surfaces. They also have metallic cores, and they are characterized by having no rings. The first of these terrestrial planets is going to be Mercury. Mercury is the closest planet to the sun, and thus it has no atmosphere and no water. Whatever atmospheric gases it did have at one time, or water, has been evaporated by the sun's intense heat. The surface is now covered in craters, and it experiences extreme temperatures because of how close it is to the sun. It has very hot days and very cold nights. Venus is usually visible from Earth, even sometimes during the day. It is characterized by its opposite spin of its orbit. It actually orbits in the opposite direction of all the other planets. It actually has a longer day than a year. It spins so slowly on its axis that its one day is equal to 243 Earth days, but its year, or the amount of time it takes to orbit around the sun, is only 225 Earth days. It does have an atmosphere. It's usually thick, and it's made up of sulfuric acid, so it would be impossible for us to live on the planet Venus. Next planet is going to be Earth. Earth is the only planet that we know of that sustains life. It has a large amount of water, and this is known as the hydrosphere. That contains all of the Earth's water, whether it's frozen or in liquid form. And this actually what helps moderate the temperatures here on Earth, keeping them relatively consistent and where we don't experience extreme temperatures as being extremely hot or extremely cold. The atmosphere here consists of about 78 to 79% nitrogen and then about 21% oxygen. And this atmosphere also helps us protect us from the radiation from the sun and also from spatial debris. Mars is going to be the last of the 4 terrestrial planets. It is usually very cold, which it's only about 144 Kelvin to 300 Kelvin. It has frozen polar caps made up of carbon dioxide. Its day length is very similar to that of Earth, and it has a very thin atmosphere, which is mostly composed of carbon dioxide. It's called the red planet due to the amount of iron oxide within its soil, and thus it looks like it's almost rusted, giving it that red planet color. And it's known for its large dust storms. Between our inner planets and our outer planets, there's the asteroid belt. Asteroids are going to be small rocky objects that orbit the sun. Most asteroids are going to be found in the solar system, are going to be located between Mars and Jupiter and be part of this asteroid belt. Within this asteroid belt is a dwarf planet known as Ceres. Ceres is going to be located in that asteroid belt. A dwarf planet is going to be a celestial body that is not considered to be a planet because it doesn't have a clear path. So it has a round surface. It orbits the sun. However, its orbital path is not clear, and thus it is going to be considered a dwarf planet. Outside of the asteroid belt is going to be our 4 planets known as the gas giants. This would be Jupiter, Saturn, Uranus, and Neptune. They are called the gas giants because they're thick, gaseous atmospheres. They do not have solid surfaces. The planet itself is all made up of gas, and it has many satellites and rings that surround it. The first of these gas giants is Jupiter. Jupiter is the largest planet within our solar system. It has more than 60 rings that surround the planet. However, they are not as thick as Saturn's rings. Its day length is only 10 hours, so it has a very short day. It spins on its axis very quickly. However, its years equal to about 12 Earth years. Jupiter has large jet streams and enormous storms. You can see on this picture, this storm right here is the Great Red Spot. It's supposed to be a large hurricane that's twice as big as Earth, and it's located on the surface of Jupiter. Jupiter is also has 4 moons that surround it. Those are known as the Galilean moons due to Galileo and his studies of the heavens. Next is Saturn. Saturn has only 40 rings, less than that of Jupiter. However, its rings are going to be thicker. And you can see those located there. They're made up of dust, rock, and ice. Saturn radiates 3 times the amount of energy that it receives from the sun, and thus scientists believe that it is still forming. The helium gas in its atmosphere is condensing, falling into the core, which then heats up those helium gas molecules and sends them back out. So what you'll see is that process of the helium falling, heating up, and being expelled outward is our evidence for it to still be forming. Uranus is going to be a blue planet that gets its color due to the methane gas that's found in its atmosphere. It's going to be very similar in shape and size to that of Neptune as well, which is our next planet. Changes in Uranus's orbit actually led to the finding of Neptune. And we know that Uranus actually is tilted 98 degrees on its axis, and thus it spins mostly on its side. And this tilt of the axis leads to the most extreme seasons in our solar system. Neptune is going to be the farthest planet from the sun. It also is blue in color due to the amount of methane gas within its atmosphere. It is very similar in shape and size to Uranus, so they're called sister planets. It has very similar storms systems, similar to that of Jupiter, and it can experience some of the craziest winds here in the galaxy, where the wind speed could actually get upwards of 1,100 kilometers per hour. If we look beyond the gas giants, we have many smaller bodies that are composed of ice and rock that lie beyond Neptune. Pluto is one of those bodies. Pluto in 2005 was downgraded from being a planet to being now a dwarf planet. The reason this is because, yes, it is round. Yes, it orbits the sun. However, it does not have a clear orbital path. And you can see that down here in the bottom right-hand picture. Pluto's on the outer edge of the Kuiper Belt, and thus its orbital path, if you were to follow that, has to pass through the Kuiper Belt in order for it to continue its orbit around the sun. And thus, the likelihood of it passing cleanly through the Kuiper Belt is very slim to none. The Kuiper Belt is going to be that region located at the very end of our solar system. It contains many smaller bodies made up of ice and rock. And within that Kuiper Belt, there's also a dwarf planet, and that is known as Eris. Okay, those are our notes.